make, model and year, and we have set a new field on the 5 series called parking assist enabled. Now to create an object of the child class, use 3 series as the variable name is equal to 3 series is the class name. Invoke the constructor. We need to pass in 4 fields here. Cruise control enabled, true. The second field is the make BMW, comma the model, which is 328i, comma the year, which is 2018. This should be true, T capital. Print 3 series dot, the first field is cruise control enabled, which is on that particular class, but the rest of them are coming from the child classes. So copy it, paste it 3 times. The second field is the make, model and year. Save it, right click, run as Python run, and the output is true, BMW 328i and 2018. So you have successfully inherited the parent class fields in the child class. You have initialized them through the child classes constructor, and you are able to reuse the fields defined in the parent class on the child class object. So everything in the parent class is available for the child class to use. That is reusability. Go ahead, create an object of 5 series. Use your favorite BMW 5 series, 535 or whatever, and create an object, display the details like this. In the previous lecture, you have seen how child classes can extend or inherit fields from a parent class. In this lecture, you will learn how to inherit methods from a parent class as well, or functionality. To do that, let's define a couple of methods on the parent class. Def start is one of the methods, which will start the car. Print starting the car. So starting a car is pretty much common for every car. So we are putting that functionality in the parent class. The next functionality is def stop the car. Save it. Let's see what the problem is here. The quotes should be terminated. Save it the same here since we have copy pasted it. The second one should say stopping the car. Now these two methods are available for both the 3 series and 5 series. You can invoke 3 series dot start the car and 3 series dot stop the car. Run the program and you will see starting the car and stopping the car. You can do the same on the 5 series as well. So functionality can be inherited as well. In addition, 3 series and 5 series can define their own methods or functions. So it can have a method def display, and it can just display the cruise controlled enabled flag. Cruise control self dot cruise controlled enabled. Run the program or invoke the display method on the 3 series before you run it. 3 series dot display is the method. Run it and you see true. Now this display method is not available on the parent class nor on the 5 series. It is only available on the 3 series. Similarly, you can define specific methods which can be available on 5 series as well, like display, which will display the parking assist enabled. But the key to understand is that you can inherit the functionality, you will inherit the functionality from the parent class, and the child classes can also define their own functionality. In this lecture, I will learn what overriding is and how simple it is to implement it. When our child classes inherit from the parent classes, sometimes they want to use the same exact method names but provide a different functionality. For example, the 3 series might offer a button start and a 5 series can offer a remote start. So, and also iPhones or any phones, as the new series come in, they have additional functionality, but you will be using the same shortcut keys or the buttons on the phone to use that functionality. So in a similar fashion here, we can override, copy this method, paste it on the child class. And here you can say, instead of starting the car, button start. Make sure the indentation is right. Invoke. Now, when we invoke the start method, we are already invoking the start method here on the 3 series. We should see button start instead of the starting the car. Execute the program and the output is button start. So we have overridden or shadowed the functionality that is available in the parent class by implementing the method with the same exact name but a different functionality in the child class. That is overriding. So using the same exact signature for a method in the child class but providing a different functionality is overriding. In this lecture, you will learn how to use the super inbuilt method that is available to invoke the parent class's constructor and parent class's methods from the child class's constructor and methods. Earlier, when you have created the child classes, you have used the parent class's name dot the init method where you have to pass the self. But you can do all that using super brackets. So super is a function that is available inbuilt in Python. Dot init will invoke the super class, which in this case is BMW's constructor, and you need not pass this self anymore. That will automatically be available. So run the program and everything will work as before. You can do the same on the 5 series as well. When we invoke the parent class's constructor, use super, which is a function, dot the init method, get rid of self from here. Save it, that's fine. And also you can use super to invoke parent classes method from child classes method. For example, here in this start, which we have overridden, if you also want to invoke the parent classes method before your own functionality, this is like adding functionality on top of existing functionality. You can use super dot start. So you're invoking the parent classes method from within the child class. Execute. Now you will see starting the car and button start. So you have got the additional functionality in the parent class as well, even though you have overridden the parent classes method. So in this lecture, you have learned how to use the inbuilt super method to invoke the constructors of the parent class as well as the methods on parent class. What is polymorphism? Poly means multi and morphic means shapes. In the world of object-oriented programming, this shapes is replaced with behavior. That is, if we can have different types of behavior or different behavior based on the data or the objects that the functions are dealing with, then that is nothing but polymorphism. There are different ways in which we can implement polymorphism in Python. The first way is using duck typing. The second way is using duck typing to do dependency injection. And you have already used the plus operator where it is overloaded to perform multiple operations. When it works with numbers, it behaves differently. With strings, it behaves differently. And with lists, it behaves differently. That is nothing but polymorphic. And finally, method overriding is also a kind of polymorphism, which is runtime polymorphism. So you are going to see all these in action in the next few lectures. Duck typing is not really a feature that a programming language offers, but it comes for free if a programming language is dynamic. So is the case in Python. Here is a method called callTalk, which takes an object. And this callTalk method is going to invoke any method on the object. The key here is that in Python, we do not specify what type of object is this. As a result, we can pass it any type of object at runtime. For example, here we have a duck class and a human class. On the duck, we can have a method called talk. On the human as well, we can have a method called talk. So if you pass a duck object to the call talk, it will invoke the talk on the duck. If you pass it a human object, it will still invoke the talk on the human object this time. So that dynamic nature, that side effect of this dynamic nature of passing parameters is nothing but duck typing. Let's see that in action. You will see the real usage of it when I discuss dependency injection in the next lecture. But for now, let's implement duck typing. Create a new PyDev project. Call it polymorphism. Select the grammar and interpreter versions. Finish. Right click, create a new file. Call it ducktypingdemo.py. The first step is to create a class called duck. Define a function called talk inside it. And the talk function simply prints quack, quack. That's how a duck talks. Now define another class called human. Def talk is the method again. But this time, instead of quacking, he will say hello. Next, create a function. Def call talk is the function name. And this takes an object as its parameter, obj dot talk. So dynamically, it invokes the talk method depending on whatever object you pass to it. Create objects here. Duck is the first one. So D is equal to duck. And you can call talk, pass in D. Similarly, create a human object. H is equal to human. Call talk. This time we are passing H, which is human. Right click. Do a run as Python run. And the output is quack quack and hello. So here we are using duck typing, which is a kind of polymorphism because the same function can do multiple things depending on what we pass to it dynamically at runtime. To see the real usage of duck typing, you should understand the concept of dependency injection. Dependency injection is nothing but simply injecting an object into another object as required. Here we have a flight that needs an engine to fly. We can inject different types of engines like the Airbus manufactured engine or the Boeing manufactured engine into this flight object dynamically. In languages like Java, if you want to dynamically inject different types of objects into another object, we'll have to first create an interface called engine, and then each of these classes should implement that interface, and then we can use that interface inside the object as a field. That gives us an opportunity to inject any of these engines because this engine is the parent interface of these two classes. So we have to write all that code simply to inject one of these objects into the flight. Thanks to the dynamic nature of Python, we need not do all that. We can simply use duck typing. Go to Eclipse, create a new file, call it flightengine.py. We're going to create a class called flight. Define a constructor, def underscore init method, self comma, this guy takes an engine so that we can do dependency injection. Self dot engine, we are defining a field called engine, is equal to engine. And we'll have a method called start engine. Inside it, you will invoke engine or self dot engine dot start. So we are assuming that these engine objects will have a method called start. Now create the next class, which is the Airbus engine, and define a method called start. Print starting Airbus engine. Copy that, paste it. Next is a Boeing engine. Copy that and paste it inside the print statements. So we have defined a flight that is dynamically accepting an engine type as a constructor parameter. We are initializing a field on the flight called engine, and inside the start engine we are using that. So here we are doing dependency injection, and we need not extend any interfaces or classes here because Python allows us to dynamically pass any type of object here. So create some objects, create the Airbus engine object, simply use AE is equal to Airbus engine, F is equal to create a flight object and pass it the AE object as the parameter. Now if you invoke F dot start engine method, let's see what happens. Right click, run as Python run, and the output is starting Airbus engine. Similarly, if you copy these three lines, paste them, this time we are going to create a BE, the Boeing engine on the right hand side. Instead of AE, pass BE, call this F1 dot start engine, run the program, and you see starting a Boeing engine. That's the beauty of duck typing in Python. So dynamically we can pass in any type of object, and that can be used within that class or object at runtime. The plus operator in Python is overloaded to perform multiple things. So we can call it polymorphic, because if you use two numbers with plus, it will add them. If you use two strings, it will append them. If you use two lists, then it will come out with a single list using those two lists. That is, it will make a single list out of the given two lists. So let's see that in action. Go to Eclipse, right click, new file, call it plus operator.py. X is equal to 10, comma, or y is equal to 20. Print x plus y. If you use it with numbers, it will add them. Use it with strings. S1 is equal to hello. S2 is equal to, within double quotes, hello or space, how are you. Print x plus y. That will do string concatenation or string appending. Last but not the least, L1 is equal to, let's define a list of numbers 1, 2, 3. L2 is equal to 4, 5, 6. Print L1 plus L2. It's going to combine those two lists together. Right click, do a run as Python run, and you will see the results. The second one should be S1 plus S2, not X plus Y. So let's change that, run it. So here it calculates the sum of the given two numbers as operands. Here it appends or concatenates the two strings, and here it comes out with a new list combining these two lists. So the plus operator is overloaded and it is polymorphic. It does multiple things depending on what you give it. You have already implemented method overriding while working with inheritance. So method overriding is a way to achieve runtime polymorphism. If you go back to your inheritance example under the inheritance project, open up the bmw.py. Scroll down here. When you create a 3 series object in languages like Java, you would specify the type on the left hand side as BMW. In Python, we don't need it, and we'll see errors if we do that. But in Java, we can do this. You can say BMW is equal to, on the right hand side, you can say 3 series or 5 series dynamically. And then you can simply invoke BMW dot these methods and these fields. So dynamically at runtime, we can switch what is there on the right hand side, but on the left hand side, we'll always have the parent interface or class. We can use the same BMW when we create the 5 series as well, and then dynamically invoke the methods on the 5 series. But in Python, again, we don't need this. Method overriding we have already implemented, but runtime polymorphism comes for free because of the dynamic typing in Python. So here we can assign any type of object to this variable. So right here we have assigned 3 series, but down here, or simply change this to BMW, copy that and use it everywhere, and we'll not see any errors. Even when we create 5 series object here, you can simply assign it to BMW. So since the variable types are dynamic, we get that runtime kind of polymorphism for free, But in programming languages like Java, on the left hand side, we use the parent class name so that we can change whatever object we are assigning to it dynamically at runtime. Using abstract classes and interfaces, we can define a contract for our child classes. That is, if we have a class called BMW and if we define an abstract method will not have any implementation and it will be marked with @abstract method decorator. Once we do that, any child class that extends or inherits this parent class will have to implement this drive method. If it doesn't implement the drive method and provide an implementation for it, then that class will also become an abstract class. And you cannot create an object of an abstract class. It exists to just provide a contract for the child classes. You can have methods in an abstract class that can have implementation. But typically at least one method in an abstract class is an abstract method. If all the methods are not abstract, then you can create an instance of that class. It is not abstract. But if at least one method in a class is an abstract method, then it becomes an abstract class. And the child classes which implement that abstract class should provide an implementation for all the abstract methods that are in the parent class. So here we are defining a contract called drive, and all the cars 3 series, 5 series and more which extend this BMW should implement the drive method using the exact number of parameters if we define any parameters. So the method signature should be exactly the same and it should provide the implementation for it. It's mandatory for a car to be driven. We implement abstract classes by using a class called ABC for abstract class. ABC stands for abstract class. It is from ABC module. You will learn how to use that in the next lecture. And also interfaces are nothing but abstract classes where all the methods are abstract. So unlike other programming languages like Java, where we have an interface keyword and then we implement an interface, in Python, an interface is simply an abstract class where all the methods are abstract. So none of the methods will have implementation. That's nothing but an interface. To implement abstract methods, we are going to go back to the BMW use case which we have worked earlier. Here we have BMW, which is the parent class with the start and stop methods, and then the 3 series and the 5 series which inherit from BMW. Now BMW wants to mandate that all these series or cars should implement a method called drive. To mandate that, we are going to use abstraction or abstract methods. Right in the parent class BMW, define a method called drive. Pass. So this now is an abstract method. This does not have any implementation. You can simply include anything here, anything within double quotes, etc. But pass specifically tells that we are not implementing this method. If you take out pass, then we'll have a problem. We'll have syntactical problem. So include pass. It's not an abstract method yet. So let's indent it properly. Save it. To implement abstraction, there are 2 steps. The first step is that we mark this method with @abstract method annotation from a module called ABC. ABC stands for abstract classes. So we are importing abstract method decorator from the ABC module and we are marking our method with it. Now this becomes an abstract method, but abstraction is not applied. Now if we run our program, it still works as it is. Do a run as Python run and you still see the output. So the 3 series does not implement this drive method and the 5 series also does not implement the drive method. But still the Python interpreter is not mandating that these classes should implement this drive method. For that to happen, our BMW class, which is an abstract class, should inherit from a class called ABC. From the same module, ABC module, there is a class called ABC, abstract class. So your class, whichever you want to be abstract, should inherit from ABC. Now save it. Now if you run it, right click, do a run as Python run, you will immediately see a problem. It says cannot instantiate abstract class 3 series with abstract method drive. Now it is mandating that all the child classes should implement the drive method. So go ahead, implement the drive method in the 3 series and 5 series. Def drive is the method, and we are overriding that method. So you can get rid of abstract method here and use a print 3 series is being driven. You can copy that, go to the 5 series and paste that code right there as well and change this to 5 series. Save it. So this is how we use abstract methods, using which we can define a contract right in the parent classes, and all the child classes should follow the exact contract defined here. So if we have any additional parameters here, we can pass those parameters, and all the child classes should also use the same exact parameter list and implement the parent method. Otherwise, you will get an error when we run our program. So let's rerun it, see if we have resolved all the problems. There we go. You can see the output. You can never instantiate an abstract class. So at the end of the program, if you try to instantiate b is equal to bmw and pass in these 3 parameters here to the bmw constructor, save it, run it, and you will see a problem. It says cannot instantiate abstract class bmw with abstract methods drive. So you have successfully seen that abstract classes cannot be instantiated. To create an abstract class and to mandate that all the child classes implement the abstract methods, we should inherit from ABC, which stands for abstract classes, which we have imported from the ABC module. Once you do that, you need to mark your abstract methods with @abstract method decorator. And then if you try to run your programs without your child classes implementing the abstract methods, you will get errors. So your child classes will implement the contract that is defined in the parent classes. In Python, interfaces are just a step above abstract classes. That is, we do not have a keyword called interface, or our child classes do not use implements keyword like we do in Java. An interface simply is a class with all the methods as abstract methods. So in this BMW, if we mark this start and stop using the @abstract method annotation, then automatically, once you do it for both these methods here, get rid of this implementation and use pass instead of having a body. Pass simply means just pass, don't do anything. We are not going to do anything. Pass again. Now this class becomes an interface, and this start and stop methods should be implemented by both the child classes. If not, we'll have a problem. We'll see that problem. But before that, get rid of this BMW instantiation at the end. Otherwise, you will see an error. We cannot instantiate BMW. It is an interface now. Run it, and you will see that the 3 series cannot instantiate abstract class 3 series with abstract method stop. So the 3 series is not implementing the stop method, although it implements the start method for us. So you can grab the start method, paste it, make sure we have the right indentation, super dot stop, and change this to button stop, and the method itself is stop. Now it implements start, stop, and the drive method as well. Same with the 5 series. The 5 series does not even implement the start method, and it also doesn't implement the stop method. Let's see what happens. We are only using the 3 series so far, so there is no issues. But if you try to create an instance of the 5 series, copy this line, paste it at the end, change this to 5 series on the right hand side as well. It should be 5 series. Save it. We have the constructor already where we are passing in all the parameters to the superclass. So run the program again and we'll see a problem. Cannot instantiate abstract class 5 series with abstract methods start and stop. So go back You can grab